All right, hello, folks. I apologize to anyone who was waiting for the delay. I have a tendency to change all the things at the same time, and I was having technical issues. So we're doing something a little bit different today, which is that instead of recording one stream per repo, we'll do. I'll try to crank out a few repos in a stream and just have a little bit of a longer stream. And what that means is it's going to there'll be like moments in between the things that will show up on YouTube as recorded streams, and that's how it is. So I have a list of things that we could possibly get to on this stream. If people show up in the chat, then what we'll do is we will vote for them. Let me see if I can get this to show up above everything else. Yeah. Okay, so here's the list as it currently stands. We have NFS, lazygit, or lazydocker, probably lazygit, Metasploit, RabbitMQ, osrm-backend, Bochs, Bochs, not like Box, Bochs, opentx, ublock origin, and Visual Studio Code. Which, am I sure that I haven't done VS Code? No, I'm not sure. At any rate, that's what we're going to do. Since this is the first one on the stream, I think I'm going to start with RabbitMQ. And this is in Erlang, so we'll take a look at it. Part of the side effect of me not knowing kind of what order I'm doing things in is that I'm gonna have to set up some of this stuff kind of on stream, which is not the ideal, but I think also not the worst thing in the world. I don't know if so let's yeah, what is it? GitHub reindex. So let's have livegrep index this repo, just because I like livegrep a bit better than GitHub. And we'll call this what, rabbit index? No such file or directory. Oh, I think I might have to recompile. Ugh. All right, well, we'll do that in the background. All right. Okay, welcome to Answer Everywhere. Today we are looking at RabbitMQ, which is a distributed message broker written mostly in Erlang. Or at least that's what they want you to think. It's written mostly in Starlark because at least this RabbitMQ server repo is largely configuration for Bazel. We can pop open the Bazel build file here, and very slowly GitHub will load it. What I see is that it's not entirely readable. So let me maybe scroll out and give some more screen space to this. They defined a bunch of their rules, and they have these things like homes and plugins, and like it's not clear to me where broker home is. It doesn't have at least super clear to me reference to a thing on the disk. But I did take a look-see around the repo, and it seems to be that the way it's laid out is that the real code for Rabbit is in deps, and calling it deps makes it kind of seem like these are dependencies that are somehow vendored in, but I didn't find a better repo for what appears to be the actual Rabbit code, which is in RabbitMQ server /deps/rabbit/source. Maybe if we look at the commit messages, I don't know if there's any sort of indication that this is pulled in from some other thing. They're certainly not Git submodules or anything. So I'm going to guess that this is just where things live. All right, and so we'll just explore from here, from dep/rabbit. And I'm supposing that most things are in source. And I've never looked at Erlang before. I don't think I've ever in my life seen an Erlang file. So we're gonna have to try to figure out what it is that that Erlang is up to, and try to read through the syntax. So I do know a couple of things about Erlang, that such as immutability, and using kind of a I don't know if it's literally CSP, but basically processes are cattle and not pets. Their processes are easy to create and to spin up and to kill, and there's some idiosyncrasies of the syntax, like having to end lines with periods as opposed to the traditional semicolon or nothing at all. So hopefully we can flub our way through. So here's CSP for the folks not in the know. Is Erlang one of these? It influenced the design of programming languages such as Limbo, Raftlib, Erlang, Go, Crystal, and Clojure's core async. And it's a formal language. I'm sure the original paper is fun, but that's not what we're here for, man. Okay. I'm going to guess rabbit.url is an important thing. AMPQ is the standard, right, for message brokers. So if you're not familiar with RabbitMQ or message brokers, then you can kind of think of it as it's a system to coordinate messages between like apps or tasks, or there's kind of the same pattern in microservices. You can think of it a little bit like an email exchange. And if you had something like a chat system, you might use RabbitMQ to ensure fault-tolerant message delivery to all of the different chat clients. So you might have the same person logged in on like 2 different mobile phones and the browser on a desktop machine, and maybe something else on a laptop. And you want to make sure that they all get the same messages in the same order and all of that sort of stuff. And that's handled by some middleware that is message passaging. So AMQP, the Advanced Message Queuing Protocol, is an open standard application layer protocol for message-oriented middleware, which is what we are. The defining features are message orientation, queuing, routing, including point-to-point, and publish and subscribe, reliability, and security. Okay, so these are the sorts of things we're doing. All right. Okay, so here's rabbit.erl, but let's go ahead and open a few other files as well. Okay, I guess we'll open this AMQQ. Presumably the Q is the same as the Q here, but spelled out. There's some stuff about auth mechanisms, which might be interesting, but I'm going to guess is not super interesting. Auto heal might be interesting because that might be about fault tolerance, which is something that you probably want to reason about in a system like this. Rabbit basic. I don't know what that's going to be about. Channel stuff, channel interceptors. Yeah, let's look at channel. Let's look at a channel interceptor, which is presumably going to possibly stand in front of a channel and do something like filtering. We have channel tracker, client sup. I don't know what sup is. Support, supreme. We have connection tracking. I'm not sure about that. Core FF. I don't know what FF is, but cuttlefish, sure. DB is presumably persisting messages to the DB. RabbitDB policy, RabbitDB queue. Let's look at DBQ. Topic exchange. I'm going to guess this is, so the Rabbit has a couple of different kinds of what it calls exchanges. So you can model Rabbit basically as a list of queues, and you can think of a queue as kind of like a mailbox. So I believe mailboxes are literally queues in this sense, but there's also the print queue, which is you send print jobs and they kind of live there until they're executed. So you can think of Rabbit as having a bunch of queues. And then there's like a router, which is maybe you can think of a little bit like React router or something, where messages first go to this router, which is called an exchange. And the exchange decides which queues to put the messages on. And then the clients somehow read from the queues. So the exchange is kind of like a thing in front of a bunch of queues. Let's see if we can find a diagram. Something like this, maybe. Here's Cloud AMQP, which is presumably more or less the same. I think this is Rabbity. Yeah, we got Rabbit MQ down here. So we have a producer, which is, I'm going to guess, is a thing that produces envelopes and or messages. And these are different types of exchange. So direct exchange, you essentially have a key, a routing key. I'm not sure what they call it, but kind of like an address, or that says like @answereverywhere@whatever.com. And that key is used to decide where to route things. In a direct exchange, I believe what happens is it goes directly to the queue that matches that particular key. For a topic exchange, you do like prefix matching. So if I'm interested in, I guess, EU.de, which presumably is messages about Germany, this will route anything that has that prefix to this queue so I can subscribe to it or whatever. And then fan out is you want to replicate the message to all of the queues. So we should see some of that. But at any rate, what I wanted to point out was that's what the exchanges are about. And then the queues are kind of down here underneath the exchanges. All right, I see some virtual host stuff. I don't care too much about that. I'll look at exchange type. And let's look at the implementations of each of these exchanges. Fan out headers. I think headers does something with routing based on the headers. Maybe HTTP-like headers, I don't know. Or TCP, I suppose. We have feature flags, which is mildly interesting, but we're not going to look at. We have FIFO, which will presumably be a FIFO queue, but now we have an HRL file. What's an HRL? Is it like a header? What is an Erlang HRL file? A header file, akin to a C include file. Okay, so some header file. Maybe it can reduce our load if we look at a few of those. But let's look at maybe FIFO and FIFO DLX. Rabbit file. We don't need GUID. We don't need limiter. I'm going to guess some sort of rate limiting. I suppose let's look at that just for fun. Logging. I think that because of the way Erlang works, I think that there's not a central log. So there's presumably some sort of distributed log. I don't know how it works, but I'll open a few of these log things. Rabbit logger exchange, header, or no, h or .url. I don't know what that's for. Looking glass has an interesting name, but I'm going to guess is about maybe observability, monitoring, metrics, logs, that sort of thing. And then we have mirror queues. I don't know what makes it a mirror, but we'll ignore that. We'll look at message record, message file. Where did message file go? Rabbit amnesia, I'm going to guess is some sort of amnesia. Maybe it's something that's in memory that goes away, doesn't persist. Maybe we'll look at it. I guess we'll look at networking. Nodes. Yeah, sure, let's look at nodes. Did I open that? Okay. Policies, plugins, I think we'll ignore. I want to make sure we get whatever the main queue thing is. So here's queue consumers. Here's queue decorator. I suppose we should look at process. Then we have queue index and queue location. And queue type. I don't think we've seen queue type. We've seen exchange type. A quorum queue. I don't know if that means that like some quorum has to agree before something happens. And we'll look at Rabbit router. SSL, I'm going to guess, is just support for essentially TLS at this point. A stream coordinator. I guess let's look at the stream coordinator header and the stream queue. Whatever a SAC coordinator is. More sup stuff. Again, I don't know what sups are about. Table. I'm going to guess tables are not the most important part of this. vhost. I'm also going to guess is not so essential. We have a VM. I'm going to guess this is like the Erlang VM. Might as well open it just to see if there's anything important about it. All right, so let's plow along. Hello. Sorry, I missed this message. Let me pop this on out here. Where is the, here we go. So if the car is asking, do I ever plan on read how Erlang does Erlang's distribution work? I'm not opposed to it. I haven't currently planned it, but I'll write that down. Is that the same as just understanding Erlang in general, or does distribution mean something in particular? All right. Also, if you're watching now, let me know how the audio is. Like, how's the volume? Is there audio interruptions? That would be super helpful. Okay, so let's take a look at these files, yay. So here's rabbit.erl. I'm going to guess this is the, one of the most important files. This, again, I've never seen an Erlang file in my life. I'm just going to guess that this is just the syntax for defining the module. We're including a bunch of stuff, presumably modules. Behavior application, I'm guessing, is saying it's a kind of app as opposed to something else. Let's see if this is an Erlang thing. Behavior. Erlang OTP behaviors for beginners. The behavior interface, which is a set of functions. Okay. The implementation is a callback module, the behavior container, which is a process. So here's an example, gen server. Okay, this is like too far in depth. Erlang behaviors and how to behave around them. Okay, so you know what I'm going to do is I'm going to just ask the AI, which I'm treating essentially more or less like a search engine. I'll say, what's the deal with behaviors in this Erlang program? The behavior directive is used to define that a module implements a certain behavior. Is that kind of like an interface? They provide a way to structure Erlang code and enforce certain patterns or interfaces. It has an application directive that indicates that the module in which this snippet is placed is expected to implement the application behavior. So is this to an interface in a language like Java? Yes. Okay. So I'm going to think of it as basically an interface. I don't know if application is a Rabbit-specific interface or if it's a general Erlang thing. We're exporting a bunch of stuff. This is kind of like familiar from Haskell. I think Erlang predates Haskell. Or maybe they're about the same time. Erlang, I think, is the 80s, right? 1986. Okay. So I'll say create an image of a 1986 programmer in where? Ericsson is what? Where is Ericsson? It's one of the AS countries. Is it Sweden? Swedish. In Sweden. So let's say create a synthwave. Okay. So interface is interface. We'll come back to you, Gemini. And then Haskell is when? 1985? So that's close. What was that's a different thing. 86. Okay, so Haskell, it sounds like maybe predates. Oh, no, Miranda is 1985. Haskell is when? I thought that didn't sound quite right. 97 is Haskell 98. Haskell 1.0 is when? When? 1990? Okay. So Erlang predates Haskell by 4 years, but like 4 years in the 80s, which is basically an eon. Okay. All right. So we're exporting a bunch of stuff. I'm going to guess this is just like Haskell. These are the functions that are going to be publicly available. And we're exporting more stuff. I don't know why we have multiple different exports. I don't know what dividing by 0 means in this context. It's obviously some sort of annotation. I don't know if this is like the number of processes or queues or something along those lines. But let's ask ChatGPT. That's pretty good. Add a Ferrari. Okay, so in the exports, what do the integers under the slash mean? Okay, so it's the arity of the function. So like how many arguments does it take? Good. Okay, so that's all fine. We call this rabbit bootstep. Maybe this is like a hook. Like these are the things that happen pre-boot. We're going to set the description to rabbit boot start, maybe so that you can log it. And then this is what is happening at boot, etc. Is it all just like this? We just have a bunch of boot steps. I'm not sure. Let's scroll down to under the boot steps. Well, here's Looking Glass. Looking Glass, Tracer, and Profiler. MFA, which I think is a kind of fighting style, is set to Rabbit Looking Glass. It requires some stuff and it enables some other stuff. And I have been clicking around to highlight, and now GitHub has jumped me down here, which is, I guess, fine. We can see how long this file is. It is forever long. It's 1,705 lines. Many of them are bootsteps, about 300-400 maybe. About, no, 273. Okay, and then we define a bunch of stuff. These look like constants, like the boot timeout is 1 times 60 times 1,000. Maybe 1,000 is microseconds and 60 is seconds. Oh, 1 minute. Okay. So that is 60 seconds. All right. And what do we have? We have the start function. Start versus boot. We want to throw an error in start. And then start, I guess, calls start it of temporary. The restart. So temporary is a restart type. I'm wondering if this is kind of like a Haskell type definition, meaning that the restart type is a type that has 3 values. It's kind of like an enum. It's either permanent or transient or temporary. That's how I'm going to read this. That might be totally wrong, but I feel confident enough to not have to ask ChatGPT for now. At any rate, we're going to start it temporary. Whatever spec means. Spec start okay. I'm guessing this is kind of like a function declaration. Start is a thing that returns okay, or that we want to return okay. And then boot. Boot versus start versus boot. We want the node to exit in boot because applications are started with transient. Any error during their startup will abort the node. And then boot also calls start at transient. How is that different? I have no idea. But maybe it is, or maybe it was, or maybe they're just called from different places. And then we have run pre-launch second phase. Finish the pre-launch phase started by RabbitMQ pre-launch application, and so on. So a lot of this looks like lifecycle stuff, which is the sort of thing you really appreciate if you use the software, I think. But not having seen any of the other source code, I think this is mainly going to kind of just look like boilerplate to us. You know, you start some stuff, you might stop some stuff. Start apps. This function should be moved over to Rabbit plugins. Okay. Handle app error. I'm aware that like Erlang error handling is maybe a little bit different in the sense that because like you expect processes to go away, the errors are the error handling is distributed in some sense, but I'm not sure exactly what sense it is. And we have things like wait for boot. Okay, so I'm just going to move along from from that file, which I guess in other languages like C kind of looks like a main function where it's like, make sure we have access to the disk, read some stuff in, call some other functions to make sure that we have like language set up. We've seen a bunch of kind of like main functions like that. So hello QSM. Maybe I can put this over here somewhere. That conflicts with me, right? Yeah, all right. Erlang, yeah, Erlang. I don't know, man. I don't know. So far, it's pretty easier to read than Perl, I think. Maybe a little bit easier to read than PHP. Is that controversial? Although I have no idea whether I have no idea whether the things I think something says are actually what it actually says. So this, I could be deluding myself. So here's Rabbit AMQ Q, where Q is like what the British people would call a line, or what programmers would call a queue. So we have some deprecated feature. This is just some like variable definition, it looks like. And then we define some consumer info keys, which is all caps, which sometimes means it's like a shell variable. Sometimes it means it's like a global in the language. But at any rate, we have what appears to be a list of some sort that has queue name, channel PID. I'm guessing PID is process ID, which I'm not sure if it's an Erlang process or an OS process, because I think those are different. A consumer tag, ACK required, which I'm going to guess is a Boolean that determines whether you require acknowledgements of your messages. Prefetch count. Something about prefetching messages, I guess, from the queue. Like how many times have you tried? Presumably like how many in a prefetch batch of some sort. Active, activity status, and arguments. And then we have the kill queue delay interval set to 100. 100 watts, maybe 100 microseconds, nanoseconds. We have some warning about file limits. This recover function. And I think I decided that spec was a way of defining a function signature. So I think this says that recover is a function that takes a virtual host. Maybe we can think of a virtual host like essentially a URL that this server is serving if it serves multiple URLs. And it returns what might be a record indicating some list of recovered stuff and a list of failed stuff. And recover, the implementation, will take the vhost argument, and presumably this is this is the function implementation equals. First, we set all durable to be an immutable variable that it holds the results of this function call find local durable queues on the vhost. So somewhere there's essentially like a map or a dictionary or a list that's indexed by vhost, and I guess we're just looking them up. And maybe it's not indexed by vhost. Maybe it's indexed by nothing and we're traversing the list. And then we call rabbit queue type recover on vhost and all durable. Okay, whatever. I'm guessing recover might be a queue type. I don't know what that means though. We have this filter function, filter PID per type, and you pass it in queue PIDs. I'm guessing these are process IDs for queues. And then we're going to partition the list, presumably, given a function, essentially a lambda, it looks like, that determines whether the PID is classic. The queue PID is classic. And then you pass it in the queue PIDs. So I guess this filters or partitions based on classic versus non-classic queue PIDs. I'm getting some sort of warning about the bit rate. So let me take a look-see on this. The current bitrate is lower than something or other. Okay, so let me take a look. Let me make sure my OBS setting is correct. I think I can't change it. So if you're watching, let me know if the video is like stuttering or anything at all. I will be re-uploading recorded versions that will not stutter. Okay, great. Thanks, QSM. Okay, so then we have stop, which will presumably stop some queues. We've got classic queues. We've got this sup stop for vhost. I guess I should figure out what sup is. But we're going to call stop for vhost on the vhost. I guess that's going to stop everything, all of the queues. Then we're going to get the environment. Passing in backing queue module, which is not passed into the stop function. So I don't know where it's defined. Maybe it's some sort of global. And then we're going to call, we get back BQ. Oh no, that's not so surprising, but we call BQ stop. This is whatever this is like something like a class or a group of functions, a module, I guess we can call the stop function on. And we pass it in a vhost. And that stops all the I guess non-classic queues perhaps. So this is not yet what I thought I would see. I thought I would see implementations of the AMQ protocol based on whatever the underlying, whatever Rabbit really wants to do. And I'm just going to scroll through and see if I see anything that's like obviously we need to implement this this function based on the standard or whatever. We've got a bunch of things like number of queues, group by nodes, retry wait. We have this AMQ, we have some called AMQ stuff, which is this a separate library or is this the current library? I don't know. Let's look at the imports. I guess this is defining what is AMPQ? AMQQ. Okay, so we're including the header. I'm not sure. Let's take a look at the header. I think we could pull that out. AMQQ dot maybe it's not here. Maybe it's somewhere else. Is it another dep? We have AMQP client. Let's do a search for, I think it's called AMQQ dot header. Here's the URL, which is different from rabbit-AMQQ, right? Do we have the HRL? Whoop. No. Well, I'm sure that I'm just missing something. But this at least is defining something AMQQ related. This seems to be a record that has things like name, whether it's durable, whether to auto delete, who the owner is, etc. And here's I guess V2 of the AMQ standard, I guess. Another record, including PIDs and stuff like that. Here's AMQ V2 pattern. I don't know what maybe this is like a pattern that's used for pattern matching in the AMQ standard. So this looks maybe more like AMQ stuff, and then perhaps the file we were looking at before was kind of taking these records and modifying them and implementing them based on the Rabbit MQ underlying queues. I could have sworn this is a thing. Can we find this? No, we can't find it. All right, well, whatever. All right, so that's enough of that. So here's auto heal. In order to auto heal, we want to find the winning partition, stop all nodes in other partitions, wait for them all to be stopped, and start them again. So is this like a network partition? What's the like cap theorem stuff? So there's this cap theorem that says you can have, I guess, what is it, like 2 of these, consistency and availability, or consistency and partition tolerance. And availability and partition tolerance, but you can't have all 3, or something along those lines. Is that right? Can provide only 2 of the following 3 guarantees. So I'm guessing this might be basically a network partition. To keep things simple, we assume all nodes are up. We don't start unless all nodes are up. And if a node goes down, we abandon the whole process. Okay, to further keep winning partition. What are we healing from, though? Is it like the partitions think they have different leaders? All right, I don't know. We'll read on. We defer the decision as to the winning node to the leader. Yeah, I guess this is like leader election. Arbitrarily selected as the first node in the cluster. So to coordinate restarting nodes, we pick a special node from the winning partition, the winner, restarting nodes, then stop, and wait for it to tell them that it's safe to start again. The winner determines that a node has stopped just by seeing if its rabbit app stops, if a node stops, etc., etc. Okay, so message flow. So this looks like it's something about leader election. It doesn't look like it says explicitly what happens to cause it to decide it has to heal, but maybe let's ask ChatGPT. In RabbitMQ, when does auto healing happen? And maybe this is just covered in the docs. Auto heal mode, disaster recovery, and high availability 101. How can I make RabbitMQ highly available? And what architectures do you recommend? Blah, blah, blah. So classic queues can be mirrored and configured for either availability or consistency. Okay. So availability is like, you're guaranteed to get an answer. Or I'm assuming this is exclusive or, as in you can't have both. Then consistency is like, regardless of which node I hit, I always get the same answer. So I'm guessing that, reading between the lines, that if you have it for availability, that you might get different answers from different queues. This is like standard behavior on the internet. If you ever have used like maybe Reddit or Facebook or a lot of places that have, for example, like likes on your post, then sometimes if you refresh the page, the like will bounce between the like count will bounce between 2 values, and that's presumably because you're hitting different machines that have different views, and it has an eventual consistency design where eventually those will converge, but in the meantime you're like hitting something that has like a temporary or old value. Using the auto heal or ignore partition handling strategies will allow all brokers in a cluster to continue serving publishers and consumers even if one or more brokers gets cut off by a network partition. Okay, it is a network partition. However, on recovering from the partition, data may be lost. All right. So ChatGPT is saying recovers from certain failures or issues without requiring manual intervention. It's designed to maintain the availability and reliability of the messaging system. So we have queue mirroring, automatic node recovery. If a node crashes or becomes unresponsive, other nodes in the cluster detect the failure and take over the responsibilities of the failed node. Okay, do they restart the failed node? Network partitioning. Yeah. This just says network partitioning can happen, and then automatic connection recovery. Okay, so this is like distributed system fallback stuff. So we have Gemini added a Ferrari. Okay. I'll say turn it into a poster for a film about Swedish 80s programmers, starring Tom Cruise. Okay. So this is AutoHeal. I guess that's interesting, but I'm not sure that we we want to read that logic through Erlang. We get a lot of the same sort of ideas as Erlang in things like Kubernetes. So like, whereas Erlang has these processes that can that are like quick to die or whatever, Kubernetes has the same thing but with like containers, something much more heavyweight. But overall, basically the same core concepts at a different level of abstraction. Here's Rabbit basic. I'm just kind of scrolling down because it seems like the beginning of the file is often maybe the stuff that's not so exciting. Here's I guess a function. If I understand spec, it's going to take an exchange name, a routing key, the decoded content. I assume maybe decoded in the sense that we maybe had an encoded string and we decoded it into bytes or something. And it's going to return an OK or an error 2. I don't know what an error 2 is. Maybe it has 2 values. Or maybe it has arity2. And I guess maybe it's just that it has arity2. So it's going to give you a message, like an error message, and an any type. So I guess you can pass back. I'm not sure this is an any type, but I'm going to guess you can pass back some object that tells you more information about the message. And the message implementation is, we're just going to call make message. So let's look at make message. In this file, make message. So that's the call to make message. Here's another call to make message. And here is presumably the implementation. I'm going to guess that this is like we saw that diagram with the exchange and the queues. I'm going to guess this is one of the entry points. All right, so make message is going to take a name and the routing key, whatever this content thing is. This maybe is like a record with properties that I guess is going to be defined by the decoded content, and some GUID, probably a global unique ID. I don't know if there's any other meaning to GUID. And we're going to do a case analysis with only one case, it looks like. So if this header routes case, I guess we're going to call this header routes function on the headers. And this case of syntax is reminiscent of how Haskell also decided to do it. So if we get an error, then we return the error, I suppose. We're just calling, there's no like return. But I'm guessing like the last thing in a block or a stanza is the thing that is the return value, as in Haskell. Otherwise, we get some routes. And then we're going to try some stuff and maybe catch some errors. And if we succeed, then we return this. It's an OK object with a basic message here. And this is, I guess, maybe why the any type was useful. Because whatever the basic message is, it might be in implementations that override make message, you might get a different kind of message, like a fancy message or a topic message. So you have basic message with the exchange name and the contents that we just get by stripping the headers. And its ID is the GUID that you passed in, whether it's persistent, and some routing keys, which is either the routing keys, it's a list of things. I think, if I understand the syntax correctly, and either the list contains things that are either routes or routing keys. But I guess routing key is the thing that's passed in here. But where does routes come from? No. This is not OR. This must be maybe concatenation. Let's ask ChatGPT. Oh, I guess it doesn't like that I asked it about a celebrity. Starring a generic, handsome 80s man. Okay, So in this code block, what does the vertical pipe mean? Whoop. It's used in list construction and pattern matching to separate the head of the list from the tail. Okay, so it's like head tail. The routing key is the head of the list and routes is the tail. Okay, fine. We're just like consing the routing key to the list. And that's routing basic. I wonder if there are other implementations of make message that at this point, I don't remember if it was an underscore or a dash. Am I not logged into GitHub here? Let me pause this for a second. All right, so no code. Maybe, was it underscore make message? We just have the one, I guess, implementation. All right, so maybe we'll see other implementations of a similar stuff. This is Python? No, NeoTalk J. This is Erlang. I am signed in another window. Okay, so here is rabbit channel. The rabbit channel processes represent an AMQP 0-9. Ooh, now. GitHub. So 0-9-1 channels. Connections parse protocol frames coming from clients and dispatch them to channel processes. Okay, so we've got some channels, which might be like a Golang chan, essentially lightweight threads or lightweight processes. And we're doing message passing between the channels. And whatever a connection is, it's going to take protocol frames from the client and I guess decide and just parse them, it sounds like, and then like hand them off to the channels. Channels are responsible for implementing the logic behind the various protocol methods involving other processes as needed. Routing messages, managing queues, keeping track of consumers, etc., transaction management. So these are the things that the channels do. Every channel has a number of dependent processes. A writer, which is responsible for sending frames to clients. So I guess a channel has, to write something, the channel like sends off a message to another process, and that process is called a writer process. And a limiter, which controls how many messages can be delivered to consumers according to active quality of service, prefetch, and internal flow control logic. Okay, so there's kind of like middleware that's used for things like slowing folks down. For a beginner, what language do I recommend? That's a good question. I feel like Python and JavaScript are both good beginner languages. There's kind of like a trade-off there. So like it might be different if you are coming from like a math or something background where you have an exposure to logic or something, because the beginner languages they make it easy to get started, but then to get a lot of stuff done, you have to really dig into frameworks, and that can become its own challenge. Whereas like other languages, like maybe Go, it's possibly a little bit harder at first, but you don't like find yourself going down a rabbit hole where you really need to understand React in order to do anything. So I think that there's a little bit of a trade-off there. But for just getting started, I think I would recommend the usual ones, which are JavaScript and Python. Yeah, I don't know. It might be good to start with Go. So Go, the background of Go, according to what the Googlers have said, how's that here from Brazil? So the idea of Go was to be like Python-like. To basically, Google was onboarding a bunch of people fresh out of college, and they wanted a language that was easy to kind of to get into the way that Python is, but didn't have the drawbacks of Python, which included, among other things, I think, just like at Google scale, like a Python app where you don't have where you have to where you have duck typing, and it's just kind of like a squishy language that becomes costly to maintain. And I think Go was trying to be a sweet spot for getting started, but also being able to write apps in a serious way that are more maintainable. So Go might be good. I mean, I don't know anyone who started programming with Go, so I don't have enough data. But I say try it out. Try to pick up Go, and if you decide it's not going where you want it to, maybe then fall back on Python or JavaScript. I think that somebody's got to do the experiment, and it could be you. All right, so here's the channel. So we get this record, which I'm going to think is basically like a struct. I guess this is going to be some config. But the state is either starting, running, flow, or closing. And then we have a protocol, which is the same as the reader's protocol. A channel number, I guess, I don't know if this is the same as the identifier, so you can talk to the channel. These are the subordinate processes, readers and writers, that we saw above. PID for the connection, and so on and so forth. Source, the originating source. For example, rabbit leader or rabbit direct or undefined. And a bunch of stuff. We have a queue collector PID. When a queue is declared as exclusive, queue collector must be notified. Okay, so I guess queue collectors may be doing something like garbage collection, and it needs to know if the queue is exclusive, I guess. And so you need to know the PID of the collector so you can talk to it. And then we have some stuff with the readers. And we have another record, which is pending ACK, which I'm going to guess is we have sent some message and we want to record the fact that we're waiting on an acknowledgement. So we have a delivery tag. I guess this is how clients, this is basically some identifier for the fact that we've delivered it. A consumer tag, I don't know what that means, but maybe that's some sort of reference to the consumer. When it was delivered, the queue name, and the message ID that I guess the thing we delivered is on the queue. Maybe this is the identifier for the message ID here. And then we have another record ch. I'm going to guess for channel. It has things like a limiter, index tag, and so on. Queue monitors. Queue processes are monitored to update queue names. Okay. And then we have statistics for presumably, what are they called? Metrics. Things like reductions, PID, transactional, confirm, etc. And we've got some stuff for recording stats, some deprecated stuff. Start link. Start link is going to take a channel number, some 3 PIDs, a string, some protocol, types user. So I guess a user host, an AMQP table, some more PIDs, and I guess it'll let you know if it succeeded or failed. I don't know what all these PIDs are for, but maybe these are like the reader and the whatever the writer, whatever we just saw above that told us that it had subordinate stuff. Okay, I'm going to kind of just plow along. We're at about an hour. I want to see how much we can see. Again, reading through Erlang, which is not something I've seen before. I want to see if there's anything else that's super fascinating. And so I'm going to kind of close these files relatively quickly. Cool. Well, thank you, Nitakje. The teaching here sucks. I'm sorry, the teaching here sucks. You're in Brazil? Is that what this means? Okay. All right. So here's channel interceptor, and we've got things like validate response, validate method, validate content. So I'm guessing this really is, as the name implies, you add an interceptor to do things like reject things, like maybe authentication might be built with an interceptor. Let's see if auth is in here. No auth. But that's good enough for me. And actually, let's ask, or maybe we'll look up Erlang processes versus OS processes. Technically, why are processes in Erlang more efficient than OS threads? I'm going to guess these are just like lightweight threads. So let's ChatGPT are Erlang processes just lightweight threads in other languages. And to make this clear, I'll say just what other languages might call lightweight threads. I don't want ChatGPT telling me that they're not literally the same thing. Okay. Basically, they're lightweight threads. They're extremely lightweight compared to operating system processes or threads in other languages. Yeah. Is there a Wikipedia entry on lightweight threads? A lightweight process. Where's my thing that I click? Okay. We have kernel threads, performance, maybe green threads. We have also fibers. I don't know how these things all differ from at a technical level. So a fiber is a particularly lightweight thread of execution. Like threads, fibers share address space. However, fibers use cooperative multitasking. Yeah, I think that's the main thing. While threads use preemptive multitasking. And then what's a green thread? A green thread is a thread that's scheduled by a runtime library or virtual machine instead of the OS. They emulate multi blah blah blah. Are they also cooperative? I'll ask, are Erlang processes cooperative? They are not cooperative. So in cooperative multitasking, tasks voluntarily yield control of the CPU to other tasks at certain points. In Erlang, however, processes are preemptively scheduled by the Erlang runtime system. Okay. Fine. So they're not, so they are, I forget what the word that we just, but basically they don't have to yield, they're not cooperative, but they are lightweight. And probably kind of similar to green threads, since I think Erlang runs on a VM. Here's Rabbit Core FF. Rabbit Core, oh, so these are feature flags. Let's just, I guess, just look at a couple of feature flags. One is quorum queue. Support queues of type quorum. All right, so that's implemented behind a feature flag. So as our stream queues and user limits. So let's see what quorum queues are. It's a modern queue type. It implements a durable replicated FIFO queue based on the Raft consensus algorithm. Okay, so we've got this Raft consensus algorithm, which is like a slightly cleaned up, I think of it as a slightly cleaned up version of Paxos consensus. It's more modern, but I don't know, like performance-wise, how they differ. Quorum queues are designed to be safer and provide simpler, well-defined failure handling semantics that users should find easier to reason about when designing and operating their system. Okay, so you know what? Just for fun, I'm going to add these to my reading list. So I'll also add streams and mirrored classic queues. I guess this rabbit logo is designed to look like a OK sign in addition to looking like a rabbit. Wait, there's a better way. I guess classic streams are not cool. Not anymore. So here's rabbit cuttlefish. I'm going to guess this is not so important. Sorry, cuttlefish. Here's the DB thing. And is virgin. Is virgin case? So this is some case analysis. If it is a virgin, we're going to log some stuff and call rabbit peer discovery sync desired clusters. At this point, the database backend could change if the node joins a cluster and that cluster uses a different database. Okay, so this is handling the fact that whatever it needs to be is virgin. We're kind of like starting out, I suppose, because we called pre-init is virgin. And so we may, things may change, I guess, before we start writing. Here's a DB queue. Is this just a queue stored in a DB? Once amnesia is removed, all transient entities will be deleted. Okay, so there's something about transientness. Maybe we'll look up rabbit DB queue. I just want to know the kind of thing it is. Hello, regular audience attendance. How's it going? I'm glad. So whatever amnesia is, it seems like this is for transient things that are only in memory. Amnesia tables. I just deleted the existing persistent volume claim and reinstalled RabbitMQ. So every time, blah, blah, blah. All right, whatever. I'm going to, so get all durable is going to take a list of queues and I guess this is kind of like a filter function. When queue maybe has type AMQ queue. So I guess every queue that has like the type or the kind of being an AMQ queue, it considers durable. And I'm going to guess that what's going on in this file is if it is durable, it gets written to the database somehow. Do we have SQL? Do we have write? Amnesia write, amnesia table. Yeah, I'm not sure. So that's maybe like a down in the weeds functionalities that we'll just squint our eyes and ignore for now. Here's the DB topic exchange, which I was mainly interested in the topic exchange. I'm going to guess this is DB support for it. We can set a topic binding by calling set, and we give, I think this might be like a record syntax thing. Erlang record syntax. Do we get the hash anywhere? Creates a new record. Maybe hash creates is the new record thing. Hash record or hash symbol record Erlang. RabbitMQ uses a different protocol, by the way. Also, the consumer has to explicitly dequeue content, else doesn't get removed from the queue. Cool. A different protocol than what? AMQ. What is it called? Is it AMQP? We looked it up before. Yeah. So I think that what we've seen, I believe, is that RabbitMQ implements like support for the AMQ stuff, but isn't. But under the hood, there's like a layer there that translates what Rabbit is really doing to what AMQ wants. Every operation like accessing, creation, and updating records are done using hash. Okay, so whatever it is, it's like some record dereferencing thing, perhaps. At any rate, so we're going to create no. What was I looking at? I was looking at binding, some sort of topic binding. Yeah. Okay. So we're going to give it a binding record, I guess, with the name, the source, the key with some binding key, which I'm going to guess is basically a string, and the destination and some arguments. And what's it going to do? We're going to call this amnesia thing. We're going to set it in amnesia, and then we're going to set in Capri. And is Capri their permanent database? The Capri application. Capri is a tree-like replicated on disk database library for Erlang and Elixir. Okay, so it's tree-like, but maybe not actually a tree. It's some database. You can store stuff to disk. And amnesia, I'm going to guess, is the in-memory version. And I don't know if this means that, I don't know if this is done transactionally. Like, I don't know if you can have stuff in amnesia, then the process like fails here and it never goes in Capri. And I don't think these are function calls. I think this is returning a record. And we're calling handle fallback on this thing. So do we have an, yeah, I think chat lags. I don't know. That might be something I can tune. So I don't know if we have a handle fallback thing, implementation that's accessible. But we call it a bunch of times. Okay, so can I click on it? No. All right. So somehow we've got these two things, and as I said, I think one is disk and one is in memory. Set in amnesia, and follow down create. Looks like maybe we're walking some sort of tree. We've got a try. So we've got a try, which is a type of tree, I believe, unless it's not quite a tree. It's essentially a fast tree. I don't know if it's the same as a prefix tree. I forget all the details here. In computer science, a trie, also called a digital tree or a prefix tree, is a type of k-array search tree, a tree data structure used for locating specific keys from within a set. So this is claiming it's the same as a prefix tree. So it's used for storing like things like strings. I don't know if we can get a better view of here. So I guess, so this is the root. This is why there's no letter in it, I suppose. But if you look at these T, TED, 10, they all share TE as a prefix, and more than that, they all share T as a prefix. So you can kind of walk down this tree quickly if you're searching for where a string is located in this data structure. And just for fun, I want to look up how Patricia trees differ. I guess Patricia trees are radix trees. How do they compare to tries? That represents a space-optimized trie in which each node that is the only child is merged with its parent. Okay, so things are merged with their parents to reduce the number of like nodes you have to walk, I suppose. All right, well that solves that. And so the topic exchange stuff is stored in trees, both it seems on disk and in memory. And I'm going to guess everything else is stored that way too. We have this match function. You're going to give it an exchange name, a routing key, and some routing options, and you're going to return a match result. It finds the topic bindings matching the given exchange and routing key, and returns the destination of the bindings, potentially with the matched binding key. And so match, we're going to, whatever maps.get is, so we're going to pass in the return binding keys. What? So I guess this looks like it might be an option. No? At any rate, I guess this is some collection of keys. Whatever false means, we're going to, I guess, try to get the binding keys. And then we're calling this Capri handle fallback function, where I think Capri is the disk-based one. And we're calling match in amnesia and match in Capri. And I'm guessing this is like the handle fallback might be if it fails in one, we fall back to the other, perhaps. Let's see if we can find rabbit Capri. I don't want to overwrite that. No, never mind. Here, we'll look at match in, I guess, Capri. We give it the transmission name, the routing key, and the whatever these B keys were, what the binding keys. And we're going to split topic key binary based on the routing keys. And we get some words. So the routing key maybe has some like paths like foo/bar/baz, and perhaps we're splitting that into separate strings, foo, comma, bar, comma, baz, or something along those lines. And then we'll call try, match, and capri, where try is TRIE and not like try catch. So this is just going to presumably look in the prefix tree for that key, which is something that you might have to do someday if you ever interview for a tech company. All right. Thanks, man. Thanks for stopping by. And I appreciate the like. Okay. Rabbit exchange type. What do we have? This is, so we've seen that there's a couple of different types of exchange. And I'm going to guess this is like the implementation of some of them. We have this callback, which I don't think we've seen a callback before, but we have it's called route. And it takes the exchange, some state, and some route options. It's going to return a list of some kind. This vertical bar we determined was essentially cons. And it's going to, as in this is the head of a list and this is the tail of the list. And the head is going to be the binding destination. And then the tail is going to be a record consisting of a queue name, named QQ name, and a binding key. So where did this binding destination come from? I'm not sure. I'm guessing this is I'm not sure how to think about this, having this type as the first thing. I don't know if this is supposed to be like a function call signature, and this is the return type, or if this is an actual function implementation. But essentially, this record is going to be, this is the queue, and here are the keys, I guess, that go to this queue. And then this is some sort of choice about the route. All right, and we have some validation stuff we can create called after declaration and recovery. All right, I'm not sure. Rabbit exchange type. I don't see really any types here. I see this function route and some validation and the ability to add bindings. I don't know. That's a little bit different than I thought it would be. Here's exchange type direct. Oh, maybe that was like stuff that's common to all types of exchanges. So here's a specific type of exchange, which is the direct exchange. And I guess we get implementations of route. So route will take this exchange struct and the message, I suppose, that we're going to route and some options. And we're going to call MC routing keys on the message. Presumably just you put the routing keys in the message, and this, I guess, maybe extracts them. And then we're going to call this rabbit DB binding match routing key and pass in the type equals direct. So we're just setting kind of like a flag to this function saying what type we are. And I guess this function's job is maybe has something like a case analysis that's going to determine which queues are matched by the routing key. And if that's the case, let's see if we can find this implementation. What? There are really no occurrences? Oh, here we go. Here's rabbit router. Is this it? We've just got the spec. I guess rabbit DB binding is where things happen. Hot path code. That's a that's a good indication. So hot path in the sense that this is probably called very frequently, once per every message or whatever. So here's the spec. And somehow they're going to pass in like the kind, right? I'm not sure. All right, so here's match routing key, and this is just calling to Amnesia and Capri. And maybe this is stuff we just already saw, but basically it's just going to look in the prefix tree for the destination. So that's not so exciting. Okay, well, I mean, it's exciting, but we've seen the we've seen the background for it. And here's the exchange type fan out, which I'm going to guess is relatively similar. So we have route, and we're going to say that where we passed in before that the type was direct, here we're going to pass in this emoji, which I think we're supposed to interpret as a literal underscore. All right. Here's the exchange type headers, and I'm going to guess we just pass in the headers type essentially. So route, we're going to, oh no, we've got a little bit of implementation. Find a way not to extract X headers unless necessary. So we're going to get the headers, we're going to get the X headers, and then call rabbit router match bindings with a name and a function. And this, I think this kind of looks like a lambda. This just seems to be like we're defining a function here that's doing some case analysis that's going to do table lookup of, for example, I guess if you pass the X match header, and based on what you've set the X match header to, we're going to call match any with different arguments. And they all have this to arity marking. And maybe this is the implementation. And I'm not sure how to read any of this stuff, but essentially we're probably presumably going to look up the key. And this is kind of just like, we need to parse the headers and figure out which function to use. Here's a topic exchange. So this should be more or less the same as the other exchanges we've seen, except now we're going to do like prefix matching instead of matching the entire key. So do we have route? Route 2 and route 3 can return duplicate destinations and duplicate key bindings. Okay, so route is going to get the routing keys from the message and append them to some list, calling db topic exchange match, on a bunch of stuff. On the name, the keys, and then whatever this double or is, setting R key to the R keys. This is maybe like a for each, like all of the matches where R key is being defined here. Let's ask ChatGPT just about the syntax. So what is the double vertical bar syntax here in Erlang? So it's some list comprehension filter. Yeah, okay. So I think that's what's going on. All right, so those are exchanges. Let's take a look at the FIFO thing. I don't know what DLX means. Something exchange. DLX consumer. We have some PID prefetch stuff. Checked out. I don't know what checked out means. Whether something is checked out. And then we just have like some records. Here's rabbit FIFO header. So we have some raft index, I guess, for leader election, and message header in memory. So, okay, so this is some macro looking stuff. This appears to be a macro. An optimized tuple. I don't know what that's about. But we're defining, I guess we have a function like is header. Is it an integer? Is it a list? We have some place to keep the raw message. We have a type for the message ID. It is consumer scoped, monotonically incrementing integer. Oh, that's the sequence number. Included with a link delivery. Okay, so we have this sequence number for the message. Yeah. Then we have a message header and size, delivery status, etc., etc. But where's the actual queue implementation? We have a consumer record, an enqueuer, which appears to be a record that has the next sequence number. So that's kind of like the list structure then. For out of order enqueues, sorted list, unused, status is either up or suspected down, I guess. And then we have a block list of some sort. It's useful to have a record of when this was blocked so that we can retry sending the block effect if the publisher did not receive the initial one. Okay, I'm not sure what blocked means. Maybe we were blocked from sending or receiving or something. Then we have a configuration, including a dead letter handler, like what to do with maybe a message that fails to deliver or something. And then we have this Rabbit FIFO record with some configuration. Messages, this seems to be the queue here. We're going to call LQ new. And I guess it has, I don't know if this is a type annotation, but it seems basically be saying it's like an LQ of message. And then we have a bunch of metadata and some enqueuers. We looked at enqueuers above. So what is LQ? Is this an Erlang thing? Is it like list queue? Module index, module LQ. Most functions in LQ were copied from OTP's queue module and amended to maintain the length of the queue. LQ implements a subset of Erlang's queue module. So this is just this, a modification of OTP, I think, is the thing that people are generally referring to when they talk about Erlang. But like, I don't know if it's like the Erlang VM, but kind of like this is essentially standard library queue implementation with some modifications is what they're saying. So it's just some queue. That's good enough for me. We have limiter. I'll ignore limiter. I'm mildly curious about logs, but maybe that's not so interesting. I'm going to guess logs just go to some logging process. These are things like message records. I think we have a sense of what a message is going to look like. It's going to have a body and some headers and stuff. Rabbit nodes. We can make nodes. We can hash some cookies. I'm guessing a node is just a thing that's running. I don't know if a node is like a machine that's running multiple Erlang processes. I'll just ask ChatGPT. In RabbitMQ, what is a node? It refers to an instance of RabbitMQ broker running on a single Erlang VM. Okay, so it's an instance of the VM. Here's queue consumers. I'm gonna guess, just because we're so long, I'm gonna guess that this is something that we have a sense of how it's gonna go. We've seen some of the channel logic. This is presumably gonna connect to one of the queues and pull messages off of it. I don't know. We can do things like add. Add what? We can go to queue name, channel. I need to remember to stop doing that on GitHub. Okay, a queue name, a channel, a C tag, a Boolean, presumably some sort of flag. I'm not sure what. We get maybe the names here. So we have a queue name, maybe child PID, no, channel PID. Whether or not we're going to require acknowledgement, the PID of the limiter, is the limiter active, I guess, prefetch stuff, args, is it empty, username, etc. So add might be like subscribe to a queue. Do we have subscribe? I'm not sure. These are held in our process dictionary. So we have this record, CR, I guess, consumer something, has a channel, monitor ref, act tags, consumer count. This seems to be like on the server side, if we're keeping track of the number of consumers, blocked consumers, limiter. So this is maybe, instead of being like a client code, which is what I initially thought when I looked at this file name, this seems like it's server code, which would make sense since we're in RabbitMQ server, that's responsible for managing their people who are subscribed to them, the consumer, managing the consumers from the server side. A queue decorator, I don't know, we'll ignore queue decorator. Rabbit process, this has things like on running node, and this other on running node indicates if the specified process runs on a member of the cluster. Of what cluster? Do you pass it in a cluster? I don't know. You give it a PID and a Boolean or something. So you give it a PID and it returns the PID, I guess, and the Boolean. It returns the PID maybe of which node it's on and whether it's actively running, I suppose. You can check if your process is alive and whether it's hibernated. So just kind of like managing processes. A queue index, is this like a database index? A queue index is responsible for recording the order of messages within a queue on disk. Yeah, so basically like an on-disk index of the stuff that's on the queue. All right, and that's, I think all of these are going to be stuff I can skip. Queue type, let's maybe take a look at queue type. We have some state. Some configuration options like whether we need to ACK, etc. Stuff we've seen before, mostly it looks like. We have some action types, indicate whether the queue type module that a message has been delivered, indicate to the queue type module that a message has been delivered fully to the queue. So we have settled, which has like, I guess, a success, like true or false, and a list of message tags. So I guess maybe these are all the messages and whether they were successful. Deliver, maybe these are messages in process and blocked. Settle OP, settle op, complete, requeue, or discard. And I guess if we, maybe we settle like after retries of, maybe we retry, and then if we like fail, maybe that's counted as settled perhaps, and then we need to decide whether we want to try to requeue or discard it or something along those lines. And that's enough for me. This quorum queue thing, something about Raft, we're not going to have the time to dig into it. Rabbit router, I think we found through looking at other files. And then stream coordinator, this is probably for stream queues, which I think that they said was less cool than quorum queues, so I'll ignore it. And then we have Rabbit VM. So let's take a quick look. We have this memory spec, which is a function that just returns some infos. So I guess this is like the about menu. Interesting sups. Sum processes. I don't know what sums are. A bunch of stuff like workers and connections and channels. Some, I guess, information about amnesia. Some stuff about quorums, etc. This seems like maybe this is like just useful information if you're an administrator. And I think that's enough for me. Okay, so that's RabbitMQ for now. If there are folks around, then let me know what you want to look at next. So can I pop this out here? I'll take maybe like a 5-minute break. I'll just like pause the stream or whatever, or turn off my mic. And we looked at RabbitMQ. So we could probably do at least one more, maybe two more. We got kind of a later start than I wanted. But between NFS, lazygit, probably, or lazydocker, or Metasploit, or these things, osrm-backend, Bochs, opentx, ublock origin, or Visual Studio. If you're in the chat, let me know if there's one of these that you want to see. Tokyo. I will write down Tokyo, but that's not in the mix for today. And currently I'm processing through a backlog that I have accumulated over a while. And so I want to get that backlog manageable before I start adding new messages to my queue, if you know what I mean. So if folks are around, I'm going to just pause this, get some more coffee, and I'll be back on in about 2 to 5 minutes, I think. All right. So lazygit, is that all right? Let's do it. Am I back on? I believe I am. All right, let's find lazygit. It's going to take me just a second just to make sure I have a local copy of lazygit. And maybe if what's it called? Is this it? Is this the official lazygit? It seems to be. All right, so let's clone lazygit, and let's also try to live grep it up. Huge delay. Let me take a look at since we're doing this kind of more raw format. Let me take a look at my chat settings and see if there's anything I can do. I might have to. How long is the delay? Is it like minutes or like seconds? So I don't think I can reset the latency. It's set to normal latency. I can ask, so YouTube normal latency. Oh. It says I should choose normal latency if I don't plan to interact with my audience. Uh-oh. Okay, so I can try, on my next stream, I will try low latency. The 20, 30, yeah, that's a pretty big delay. So the constraint I'm working with here is that I live in the woods, and so my internet isn't as fast as it could be. No, I think that's just the standard default YouTube latency is my guess. And so like the trade-off is like if I bump up the latency, there might be more like stuttering on YouTube. YouTube says it won't be able to support as high a resolution, which I don't think I'm streaming at a super high resolution yet. And with my internet, it might be not so great, but I'll try that I will try that for next stream. I'm recording these to as a higher quality video as well. So I guess even if there's like problems on the stream, it won't be the end of the world. I have to figure out how to serve this index, which I think I just called lazygit. Something like this. All right, is this working? Lazygit. All right. Cool. All right. And let's create new chats so that we're not influenced by our RabbitMQ chats. Hello, and welcome to Ants Are Everywhere. Today we're taking a look at lazygit, which is a simple terminal UI for Git commands. I don't know what language it's written I've seen screenshots of lazygit. I've never used it before, but I'm going to guess it's some kind of I don't know if this is end curses or something else, but it's like a Git-ish UI that is maybe similar in spirit to something like Magit for Emacs. Okay, maybe a Git porcelain is what it's called. So what do we have? We're at version 0.40.2. So I guess we're not quite at 1. Are we using 0 based versioning? 0 var. 0 based versioning. Major versions are over. Yes. Starts with a 0. No. Starts with a 1 or a 2. Or a higher integer. Okay. And you can donate. So what language are we in? Go. 99.7% Go. And 0.3% other. Okay. So we've looked at several Golang programs before. This will probably be a little bit different because we're doing not networky stuff. We're doing command line-y stuff. Package. This looks large. This looks like a relatively large repo. What kind of Linux am I using? I'm using pretty stock Linux Mint, which is basically like Ubuntu with some of the more annoying parts of Ubuntu removed. And it's okay. But this is like a VM. I tried running it on my main machine, but I wasn't so happy with how it handled things like audio and video cards. Okay, so this is packages. I think package is where Go people put their stuff. Test might be useful. And command, I think, is typically just command line argument parsing and stuff. Yeah, that seems to be what this is about. We've got like a usage help command, it looks like. Okay, so do we want to look in tests? Doesn't seem like a huge amount here in tests. Okay. Snake. We have to start at snake and snake.go. It's a game. It's just a snake game, I think. So do I have lazygit? What are my options here? Let me take a look at if Linux Mint has lazygit. How to install on Ubuntu? So I would need to add a repo. I'm tempted, but I'm not going to do that, I think. As much as I want to play Snake. Okay, so we've got a Snake implementation. I'm going to assume that's more or less, so it feels a little bit more like Emacs. You can do non-relevant things in your terminal. Should we look at the Snake? I guess we should at some point look at a Snake implementation. Might as well be now. So you've got this type game struct, which is a width and height. It's got a width and height of the board. A render function, which is going to take a list of cells. So a cell is essentially a list of lists, a 2D grid, if you will, and alive. If alive is false, the cells are expected to be ignored. If you have Go, I can install from that. I don't know if I do have Go. Oops. I do have Go. Let me look at the installation instructions. All right. Good point. Whoops. All right. As we so let's go back. We've got a channel for, I guess, communicating stuff. Closed when the game is exited. Or maybe that's just for checking when things are done. And then we have a channel for specifying the direction that you want to go in and a logger function. and a random integer function. Putting this on the struct for deterministic testing. Okay, so I think normally you would just specify the seed of your rand thing, but this seems to be like a function that you can specify like how it will return. Then we have state, which is the snake positions. The first element is the head, and then the final is the tail. So you just have the snake is encoded as a series of, let's just consider them ones, I guess on, off, or maybe this is like cell locations. The food position, this is I guess where like food is located that you can eat. The direction that the snake is going in, which is essentially the first derivative of the head, I would think. And then the last tick direction, the direction as of the end of the last tick. We hold on to this so that the snake can't do a 180-degree turn in between ticks. Then the position is just, we just have this struct to keep the XY coordinates. Direction is an int. I don't know how it encodes direction, presumably north, south, east, west. Const, up direction equals iota. Then we have down, left, right. Hey, stop it, GitHub. And then we have the cell type is just an int. So I guess cells are just considered to be ints. And then we have whatever this is. I guess the cell can have either a snake or food or nothing in it. And then for a new game, we just return this game struct with some default options or whatever options you pass in. And then when you start, you call self.gameloop. What is self here? Oh, game. You call game loop on the game. And then exit, you call close. And then set direction will set, you pass it in a direction that sets the, I guess, sends the direction to the channel, I think is what this index is doing. And so the game loop, we make sure we're initialized. We render the cells, which is at this point, I guess, just the starting position. And then we get a new ticker, a time ticker. This is presumably something that's going to emit ticks every 75 milliseconds. And I think that this is just kind of looking for messages. So if we get exit, we end. If we get set new direction, we'll set the new direction. If we get a ticker, then we'll call self.tick on the state. And that will give us the state, I guess the old state, and that'll give us the new state and whether we are alive, perhaps. And we'll render the cells passing in alive. And if we're not alive, return. I guess alive is whether the whole snake is alive. And then initialize state, we'll do what? We'll find the center of the screen, set the snake positions to be, I guess, at the center of the screen, and set some food where, add a new food position based on the snake positions. Okay. And how are we setting the new food position? With random ends, it looks like. Okay. That's I think enough. That's enough. So let's try typing. How do I do it? Go run lazygit. Sure. No. Let's run it on the lazygit repository. Thank you for using lazygit. All right. So the question, the main question is, how do I play snake? So if I hit, how do I get help? That's my terminal thing. S. That's dash changes. L is presumably log, or maybe is this local branch? Okay, so this is, I guess, a log of the local branch. Can I do C? C seems to open up branch thing. What about capital C? How do I commit? Maybe it won't let me commit if I haven't changed anything. So here's the, so checkout is C. Where's commit? Create tag. View commits is enter. You can switch between repos. R is refresh, push, pull. Push is capital P, pull is little p. You can create a pull request. Whoop, no, don't do that. Just delete branch. Fast forward this branch from upstream, create tag. I don't know if I can create a new commit unless that's not a tag. I'm thinking refs. Maybe that doesn't make sense outside an editor anyway. And then how do I play snake? We have snake controller. I don't, I don't know what on earth we're doing here. Helpers, commits, snake helper. Let's look for, so the copy branch name. So let's look for key bindings. I guess while we're here, we might as well look at how the key bindings are implemented. So we have these functions. They take in a GUI thing, GUI kind of like object. I forget what Go calls them, but basically a struct that has behaviors. No pop-up panel, outside filter, validate not in filter mode, get cheat sheet key bindings, only to be called from the cheat sheet generate script. Okay, so this I guess is maybe generated like a PDF or a printout sheet. I'm not sure, some sort of script with cheat sheets. We have key binding ops, which has some user config key binding thing and some guards. What are the guards doing? I'm not sure, but they've got this outside filter mode and no pop-up panel, which we saw up here. So let's take a look at these. So no pop-up panel, you're gonna give it a function. I'm not sure I remember what the syntax is, but I think this is kind of like a lambda, right? Golang lambda. Or maybe they just call them a non, we'll call them lambda. I'll ask ChatGPT. No, I'll ask Gemini. What's up with the argument? So I'll say, what's up with the function argument syntax here? Yeah, okay, so there's no pop-up GUI. What I want to know is func error. Accepts one argument f of type func error, meaning a function that takes no arguments and returns an error. Okay, so I guess I was just, I had forgotten that there's just this space between the function and its return type. So it takes, I guess, a void function that returns an error, and it returns a void function that returns an error. All right. And we're going to return func error of this, I guess, this new function that is going to do what? We'll check if GUI helper's confirmation is pop-up panel focused. So we're going to, I guess, see if the pop-up panel has focus. We're going to return nil. Otherwise, we're going to return the function that you passed in. And so this, I guess, is like, how do you want to handle if we're not in the pop-up panel? And then Trivenzi is saying, how can you read code for projects that you rarely or have never used before? That's a good question. And so the basic answer is just practice. So you eventually, like, on big enough projects, you'll have to understand like the code of like your coworkers, um, and uh, and so you just like no matter what, eventually, I think you're going to have to be put into a position where you're reading code for something that maybe you use like transitively in some sense, but you have no familiarity with, and so you just kind of get used to it after a while, and there's a sense in which the code is the truth of what the program is doing, and so in that sense it kind of like trumps documentation, for example. And for tips, I guess my main tip is just it's one of those things that's like almost like muscle memory practice, where you just kind of have to do it enough to figure out. Sorry about this mic stuff. You just have to do it enough to figure out what you find challenging about it, and kind of drill down into those things. And it's largely just a matter of practice. Although it helps to have a solid foundation in writing code in some language, ideally a couple of languages, just so you're familiar intuitively with the fact that a language can kind of look radically different, but still have a way of expressing things that you're familiar with. And you were saying that's just a function of, yes, thank you. I appreciate the help. I think that there's a delay here, and I probably just didn't see when you put that. But what I was confused about is just like what is what. And I had forgotten that, because like here on the left, func comes before the name of the function. Here func comes after the name of the function. So I just had forgotten that Go has that peculiarity, and I wanted to make sure that was what was going on. And similarly, outside filter mode seems to have a similar behavior. So if we are if we're outside of the if the GUI will not validate that we're not in filter mode, I guess we are in filter mode, then we return a nil. Otherwise, we return this function here. So it's a way of like configuring behavior based on some GUI state, I think. And then here's validate not in filter mode, which is called here. And it's going to return a bool. And we'll check if state modes, filtering active. And this is, we'll call confirm on the confirm opts with this stuff. It's a given title prompt in handle confirm. And we'll ignore the result. And we'll return false. What? And then otherwise we'll return true. I'm not sure why we're calling this. Maybe, I don't know if this like causes a side effect. And I don't know what happens if like this, something terrible happens when this is called, because it seems like no matter what it returns, we're going to return false. But I guess that's fine. I'll ask, why do we ignore the return value of GUI? Was it something like that? GUI.c.confirm? Is being ignored by user under, this is a common practice, blah, blah, blah. Likely displays a confirmation dialog to the user based on the provided option. The return value might indicate whether the user has confirmed or canceled the action. However, the function is mainly used for its side effects. Yeah, okay, so it's just doing a side effect, and I guess it doesn't matter what whatever the user says, we're just going to ignore their intent, I guess, or for this purpose, their intent doesn't matter. Okay, so we have this get initial key bindings, which is, I'm going to guess, where the things are configured. And I don't know why view name is the empty string here, But we have things like scroll down main, scroll up all. And then we have files, local branches, remote branches, commits, subcommits, information, secondary main. So mouse wheel up. I guess like if we're, maybe this is like if we're in the main view, then the mouse wheel up, when you move the mouse wheel, you will, we'll call, I guess, this handler scroll up main with whatever, I don't know what description means. And the alternative is function down. So what is go QE? I guess console UI. Minimalist Go package aimed at creating a console user interface. Okay. All right, so this is, I think that this is what this is saying, that if we're in this view, given this key, here's the handler, here's some description of it, and then we might have an alternative key. So in the confirmation view, I guess, we have next item alt. I don't know what that is. Mode none and scroll confirmation panel. Cool. What about log? So if we go back to here, let's see if we can find something like new branch. So maybe the strings are in the description. Maybe this is some stuff that is behind like a localization library. So let's look for a new branch. Key bindings English.md. So we have create new branch. So new branch. Is this the code? I think this is actually the code, not just a comment, or maybe it is. I'm going to guess that this is, although this is a markdown file, no, this file is auto-generated. To update, make the changes in the package I18N internationalization and then run go generate. Okay, so let's look in I18N. So it is a doc. Okay, so where is internationalization? I don't think we've really looked at internationalization, but we might as well. Here's english.go. We have a translation set struct, which has things like not enough space, diff title, branches title. So I guess these are maybe things that need to be translated. And this is like an identifier in English, but in code, perhaps. And then this is telling you that the type is string. And then do we get a translation for them? What if we just search for checkout prompt? Okay, so then there's some large mapping here that says the checkout prompt is, are you sure you want to check out %s? Question mark. And then this is presumably going to be called something like printf, or whatever the Go version of printf is. And so these are just mappings of strings to, and then what's a language that I can at least read the alphabet of? Dutch? No. I can't read the Russian alphabet. Yeah, all right. So, so here in the translation set, again, on the left-hand side, we have the English, the English words, and I assume this is because this is how they appear in the code. But if we search for checkout prompt, instead of seeing like string over here, which was their type, we see just the map that redefines them. Checkout prompt. Checkout commit is just set to checkout commit, but git flow options is set to lot git flow optisieren. Is it good to have so many attributes in a struct like that? I don't know. I think that there's some stuff for structs that matters for cache behavior, but I think it's not so much the absolute items in the struct. I think it's more about how close together, like items that you use together a lot. You want to be close together, but I'm not sure if there's any actual downside to having a large struct in C. And I know even less about Go, but I will ask the AIs. And what do I think about Go? Is it better than that's a good question. I enjoy programming in Java more than I enjoy programming in Go. But there is something nice about Go. It's you get it's like relatively lightweight. It compiles nicely. The thing that I think about Go, and I've never seen anyone say this, but the nice things about Go, like the way it does error handling, where it like returns two values, or like the use of channels, all of that stuff pretty closely mirrors, in my opinion, the like the way that C++ is written internally at Google. And I think when I looked it up, the C++ stuff predated Go, and it's since then been released under the name Abseil, like a version of the C++ libraries. So I kind of feel like my reading on Go is that it like took a bunch of programming patterns that were in use at Google at the time and tried to make a language that like encoded those patterns in a more usable format. And so the stuff that I like about Go is the stuff that's similar to how C++ is used, because I think that was really nice as a developer experience for C++. But the stuff that's specific to Go, from like given that framework, is not stuff that I'm like super excited about. But I will ask, in Go, is it bad to have large structs? Say structs containing 100 items. Let's give it an arbitrary number. So potential downsides: memory usage, performance, maintainability, passed by value. By default, structs are passed by value in Go. This can be inefficient for large structs, as the entire struct is copied on each function call. So you can group them together, and you might, I guess, share data, analyze usage, prioritize clarity, measure performance. Those are the standard recommendations. So Gemini seems to think that it is bad. Let's ask ChatGPT. And while they're answering, let's go back here. I don't know if this is actually a struct, though. I think this is a map, right? I don't know. Translation set. Go translation set. Maybe translation set is their own. So yeah, okay, yeah. That was the thing we were looking at that had string. This is the definition of the struct type. Yeah, maybe it is bad. How many actually are there? Like over 100. In Go, having large structs isn't inherently bad, but it can lead to some potential issues that you should be aware of and consider when designing your application. Large structs consume more memory. Performance. Operations involving large structs might be slower. However, modern hardware can often mitigate this concern to some extent. Complexity, serialization, and deserialization. Readability, maintainability. And it says you can split stuff into smaller structs, etc., etc. Yeah, that's what they're saying. I don't know how much it matters. But I will ask about what about in C? What do I like about Java? Yeah, there's a lot of... so Java is kind of feels like this designed by committee language. It's older. It had, for a long time, it didn't have many features. And it's verbose. So a lot of people prefer it not being so verbose. I guess the thing that I really liked about it is it was the tooling was very good, and I think it's very good because partially because of the verbosity. And like I've never worked in a language where it's so easy to like refactor things. It has a lot of boilerplate, which is ugly. But the tooling is so good, and that makes a big difference. In contrast, I haven't been so in love with the Go tooling, but I think there are people who do love the Go tooling a lot. And I think Java was just my comparison point because you asked about it if it's better than Java. If it's better than Java. I tend not to think of languages as being better than or worse than one another. I tend to think in terms of like, given the constraints of this particular problem, what should we use today? And that kind of assumes a lot about your ability to choose a language. The fewer languages the more your decision will be just based on what you have familiarity with. But I think after a certain extent of using different languages, you kind of get more of a feel for like, this would be terrible to write in Java. Let's do it in Go or something like that. But I haven't used Java in several years, so I'm not like up to date on stuff. All right. So that's so we were just looking at the translation stuff, and what did I do with it? Did I close that file? What I really want to know is, where can I find Snake? Can I play Snake? I need to play Snake. We have a Snake context key. Maybe there's the documentation. Adding Snake to lazygit. I don't know. Do we have a... So here's the commit. And the commit seems to be just about Snake. We have the controllers, Snake views. You died, Snake title. Okay. Command. I guess maybe you have to pass it a command argument. This diff was deleted. So maybe you, wait, Snake command. Here's the Snake game itself. I wonder if you have to pass it a particular command line argument. Here's generate.go. But why, I don't know why this is in the Snake stuff. Key A. All right. So let's try passing help. Can I do help? Path, filter, version, logs, tree. I'm not sure. Let's keep going through and see if we could find out how you actually invoke the Snake game. All right. So let's take a look at GUI. We've seen a couple of the GUI things already. Integration might be just integration tests. Constants, maybe common is important. Commands might be important. The cheat sheet and the app. I'm not sure which of these are the most important. Tasks might be for like scheduling, maybe like background tasks. Updates may not be so important, and utils. Okay, so we looked at translations. That was actually a little bit informative just because we haven't taken a look at translation stuff before, but that's more or less how I think translations are handled in all languages. You have some kind of program-friendly identifier that refers to a string, and then you have a mapping from those identifiers to the strings in the different languages. All right, this is just kind of like the GitHub page. Here's Go QE, which is one of the dependencies. Here's GUI. Maybe I'll move GUI. Tried looking for snake everywhere. Couldn't find anything. Yeah, what's up? So how, okay. In lazygit, how do I play snake? By pressing S. Did I not try that? Don't lie to me, ChatGPT. Where did my other terminal go? Oh, I'm in the wrong workspace. Let's try this again. S is stash changes. What about here? S is stash changes. You don't know anything, ChatGPT. You're a liar. Let's ask Gemini. Unfortunately, playing snake directly within lazygit isn't currently possible. Are you positive? Let's ask this AI thing, this other AI thing. Click on File, Load Repository. Press the snake key, usually S. That's the same thing that ChatGPT told me. What if I just started with no, well. All right, whatever. Maybe it's not possible to play, and maybe we will find out how to play it by reading the code. Okay, so in the GUI, we have a context controllers, file tree, key bindings, merge conflicts. That's, I guess, for handling merge conflicts, or maybe just displaying merge conflicts. I don't know what context would be. Controller might be controllers in the sense of the GUI model view controller type stuff. Modes. This might be like different modes for displaying like logs or whatever. Patch exploring. Pop-ups. We'll ignore pop-ups. Presentation. I'm not sure if we need presentation. Background, context, controllers. So these are the, we'll just take a look at these Go files, and then if they look interesting enough, we'll take a look at the corresponding folders. Main panels. So presumably this is using the QE library for the most part to get. I did try Shift S. I forget what happened, but let's try it again. Nothing happened. What if we run it? What if we run it outside of? I think I've. What have I done? Escape is now doing nothing. Let's try. What do I need to do? Give it the like GitHub URL or something. What? All right, where's my, this is not, for some reason it seems to be stuck. I can't escape. I can't quit. So whatever is going on, either lazygit has frozen or the terminal is frozen. So I guess I'll have to close this and look up how to close terminal. Look up whatever the command was that I called to install it. Oh, I needed the latest tag. Is that what went wrong? So if I create it in a place that's not a repository, I can still stash changes. And then if I do capital S, I get stash options. And I'm not sure. Maybe you have to donate to get access to Snake. All right, so where was I? Utilities, no. Oh, I had my own, GUI had its own thing. Okay. All right, so GUI key bindings, I think we looked at already. We have a bunch of Go QE stuff, like right, left, anything Snake related. No. All right, we have functions like getKey, which is going to take a string. It's going to return a key type. I guess types is a place where type information or where common types are defined just to keep everything in the same place. And we have this rune count and string thing. I think runes are what Go calls UTF-8 or something along those lines. And we check if the key is disabled, in which case we return nil, basically a no op. Otherwise, we look at the rune count, check if it's larger than 1. And then we set the key to lowercase, look it up in the key by label dictionary or map or whatever it's called, and we get a binding and possibly some thing indicating whether we succeeded or failed. And if we succeeded, then we'll return the binding, the key binding. Otherwise, if the rune count is exactly 1, then we just look up the 0 index of the key in the rune, I guess. I'm not sure what it means for the rune count to differ here, but that's what it is. We have this label from key. This is presumably just going to look up the key again in some container. Here, we're going to look up label by key again. Okay. So that's key bindings. It's relatively small, kind of like utility methods. Maybe it looks like here's merge conflicts. You have find conflicts.go, find conflicts test, merge conflict, rendering, state, and state test. So let's look at find conflicts, rendering, and state. And I'm wondering if this is going to tell us a little bit about the way to think about GUIs here. Find conflicts is probably going to be the most complicated, but let's take a look at state. State represents the selection state of the merge conflict context. So we have a path of a file with conflicts, and we have a stack of the file content. It's used to undo changes. Okay, so I guess each time the content is changed, we put something on the stack, and then as we undo, we pop off. And then we have a list of merge conflicts. And an index. This is the index of the above conflicts field, which something or other, which is currently selected. And then we have an index of the selected conflicts available selection slice. For example, top, middle, or bottom. So that's like, I think that's for like keep top versus keep bottom, accept ours or accept theirs sort of thing. We can create a new state, which has the indices set to 0. We have like setters for the conflict index. We can get the next selection hunk, which we just do by adding 1 to the index, etc. So this is all kind of straightforward. Undo, we take a look at the contents is less than or equal to 1, in which case we return false. Otherwise, we set contents to the previous thing. This is like popping the top one off the stacks. Although I guess we can redo by, no, we can't. We're truncating. So we truncate contents, and then we set new content. We get by calling s.getContent, and we set the conflicts by finding the conflicts with the new content and return true. Why do we find the contents? We have this comment here, but basically before looking at the comment, it's presumably so that we don't have, like if we undid we want to not look at contents from the stuff we threw away. We could be storing the old conflicts and select the index on a stack too. Okay. So that's all relatively straightforward. We don't yet know how to display conflicts, but I'm going to guess this is kind of just like a standard diffing algorithm. Colored conflict file. So you pass it in a state, and we're going to call it get content on the state. Check the length. We're going to shift conflict. I guess this is, I don't know what it means to shift. Maybe like go to the next one. We get a conflict and remaining conflicts back. Then we create these variables for the output buffer. Or I guess we create a single variable of type bytes buffer, maybe, if I remember Go. And then we iterate over the content, calling split lines. So we get, I guess, like an index and a line. And then we set the text style to the default text color based on the theme. And if conflict is marker line, we'll set it to red. Okay, so if there's a, if the line we're on is a line that we believe to have a conflict on it, we'll color the line red by setting the text style to style.fg red. And if the line is the end of a conflict and we have more than and we have some remaining conflicts, we're not done, then we're going to set conflict and remaining conflicts to shift conflicts. We're going to, I guess, move along the conflicts. And then at each iteration of the loop, we're going to write to the buffer the line that we were just looking at with its text style. And then at the end, we're going to return the output buffer because we're kind of doing a string builder type thing. Klaus for the win. We are doing well. How are you doing? And then here's shift conflicts. We're just returning conflicts 0. And conflicts, I guess the remainder. This is like maybe like head, tail. I don't know. So that's rendering. But we're just sending the output buffer. So something else, I guess, is in charge of like printing that buffer to the screen. Is it? Maybe we're dealing with like command line stuff, so I don't really know how that works. Find conflicts. This will do the finding conflicts. I'm surprised that we can't just get a diff from git. So we keep track of the start line, the ancestor, the target, and not a marker. These are just constants. Find conflicts. You give it a content, and it'll return you a list of merge conflicts. So we split up the lines, and we call determine line type, and maybe that's doing the actual judgment. And if we're at the start of a conflict, I guess we say that we are a new merge conflict whose ancestor is -1. If we get an ancestor back, if new conflict is non-nil, then new conflict ancestor is 1. And if we're a target, we'll set new conflict to, and new conflict is non-nil, we'll set the target to 1, to I. So I think I said 1 here, but to I. So this is saying, so new conflict was declared up here. Gosh darn it, GitHub. GitHub is really bad at actually finding what you're clicking on. So I'm not sure why they should just they should just either give up or make their functionality better. But I'm not sure what so ancestor I think is saying that if I have a multi-line conflict, the ancestor is the line before it that was a conflict, and I guess you can chain up the ancestors to find where the start was. Target, I'm not sure really what it's doing. Then end, I think, is just the opposite of start. We're at the bottom of a conflict. Default, this isn't a merge conflict marker, so we just continue. So conflict start has this much less than sign. Conflict end has the much greater than sign. And then we, I guess, keep we take these and turn them into bytes for more byte-friendly processing. And then determine line type, I guess, is the thing that actually does the checking. And we do that by, we pass in a single line. Find out whether we ever actually get this prefix. So we trim the thing we passed in. I don't know what the plus does, but we do some sort of trimming. Then we check the prefix. And if it's a conflict start, we return. Okay, so this was kind of what I was wondering. So it seems like the lines we're operating on are the lines we get back from Git, where the conflicts are already populated, and we're just looking at them to see like how we should display them. And so this is just like, do we have conflict markers and so on and so forth. Okay, so that's fine. Merge conflict.go, did we already look at that? A merge conflict. A Git conflict with a start, ancestor if exists, target, and end corresponding to the line numbers. Maybe target is like the line, like if you add a new line, maybe the target is like where the line goes in the next version of the file. Okay, so the real conflict stuff is really being done by Git, and this is kind of just like display information, which is what you would expect from a GUI application. Here's GUI context. We have base context, commit files context, context.go, dynamic tile builder. I don't know what these are supposed to be doing. So let's look at dynamic title builder. This is, maybe these are like small utility methods. We have a string, and we're going to build a title of some sort with this format string. And the format string can have like unresolved templating stuff, like remote branches for %s, and these will be somehow filled in. And this is kind of like utilities for managing that. What is context.go? I'm not sure. We have a bunch of context keys. File context key, snake context key. I don't think we're any closer to knowing how to play, but we at least have a context key, global context key. I don't know if this is telling you where, like what view you're on. Local branches, remotes, stash. These kind of seem like they correspond to views. And then we have some things down here. These shouldn't really be for anything, but I'm giving them unique keys nonetheless. App status, context key, etc. Let's see if GoQE context key. Let's see if context keys are a thing in GoQE. I can try using a fuzzy finder tool to browse code. Some configs HV that built in. Some neovim configs. I don't know what HV means here. Thank you, Omar. Just found this amazing channel. Keep it up. Thanks, I appreciate it. And I don't know what you mean by fuzzy finder. Is it just the same as fuzzy search? I actually forget how closely. Yeah, that's a good point. Have that built in. Okay. Yeah, that's a good point. Do you mean for a snake? Because I don't know if that would help in this particular case. But it's true that I don't think I have a good way of doing fuzzy finding. Although maybe GitHub does it by default. What was I doing? So context keys, I'm not sure if this is just like a Go pattern or a thing that lazygit is cooking up themselves or something else. It doesn't seem to be something specifically QE related. All right, but at any rate, we have a bunch of different context keys that will keep track of like what sort of thing we're doing. Then we have this context tree struct, global status. So I guess the some of these contexts are global status, files, menu, branches, work trees, etc., snake, and then some display stuff like app status options. And then the order of this decides which context is initially at the top of its window. So somehow we're going to flatten this list. This seems like a flat list already. I'm not sure what we are flattening. This says it's a tree, but it doesn't seem so tree. Oh, I guess maybe because of the inheritance. So let's look for patch explorer context. Yeah, I'm not really sure in what sense this is supposed to be a tree. Stash context. But at any rate, this somehow the order of this list has something to do with the ordering of modules and stuff, or like the layout of the window. And how that is, I'm not sure. Controllers. So let's pick one. Let's like pick a random victim, I guess. Files controller, list controller, merge conflicts controller. How about search controller? We've got new search controller factory, and you pass it in a controller common, which is, I guess, just like a generic type that's used for like the API or something. And we'll get back a search controller factory, and we just return one of these. And to create one, you take a context, which is the searchable context, and you get back a search controller, which has a base controller, a reference to, I guess, itself, and a context, namely the context you passed in. And what can you do? You can get the key bindings, and you can open search prompt, which calls self.c.helpers search open search prompt. So is .c the is the controller common? Okay, I'm not really sure why we're doing this, but overall what's happening is by calling create, we now have an object where we can ask it to open the search prompt. But all that's doing is I guess it's delegating into this common thing, which I think is what C is, and looking at the helpers, finding the search helper, and calling open search prompt. So it kind of seems like there's a sense in which all that's really going on is it's kind of a nicer interface than just calling this directly. And you can like phrase your APIs in terms of this search controller stuff without, as opposed to just, this is kind of like an implementation detail, I think is maybe the way to think about this. Let's look at attach. Attach controllers. So you can, attach controllers will take a context and some controllers and essentially iterate over them and add a key bindings function, add mouse key bindings, add on-click functions by delegating to the caller. So we're calling on context, we're calling like add key bindings. What are we adding? The controller.key bindings. So this is like populating context stuff based on the controller stuff you passed in. I'm not sure, is that a common use of context? Seems like context is maybe doing too much work here. Like my familiarity with Go context, I thought they were like pretty lightweight things. It seems like these contexts have a bunch of, they're like keeping track of like managing objects and stuff. All right, base controller. Base controller has things, so it's an empty struct. So it's really just there for defining which functions are valid on it. So get key bindings, get mouse key bindings, get on click, the functions we saw before. So this is just some way of defining an interface that essentially we're basically doing inheritance with like a custom rolled inheritance thing. So this is an interface, and the things like search, whatever we call it, search controller, inherit from this or implement this interface in some sense. And then we have the this kind of like indirection stuff we saw where we're like adding stuff to the context but did we see helper? I'm not sure we saw helper. Help. We have helpers. Bisect helper. I'm guessing that's for git bisect. Do we have search helper? Here's search helper. Note, this helper supports both filtering and searching. Filtering is when the contents of the list are filtered, whereas searching does not actually change the content of the list, but instead just highlights the search. Okay, so that we have this new search helper, an open filter prompt, which I think is the function we saw called before, and we pass in a filterable context. And what are we doing? We've got search prefix view, set content. So somehow we're doing some prefix stuff with filters, changing the prompts. I'm not sure. Display filter status. So this prompt view stuff, where does that come from? We are importing a bunch of Go QE stuff. And we're getting the prompt view from self.prompt view. Do we get a definition? Okay, so it's a Go QE view. Okay, so what the helpers are doing, it looks like, are they are the bridge between the world of lazygit and the underlying implementation library, which is Go QE, I think is probably the way to think about it. Here's modes. You can have different modes, like are you cherry picking, are you diffing, filtering. Okay, I'm not sure why these are called modes, but I think it's because they like you might need to look at logs, for example, while you're cherry picking, and that might have a slightly different view compared to just looking at logs normally. So, but I'm not sure. I'm gonna just kind of move along. Patch exploring. Let's ignore controllers.go. Did we look at this already? Reset helpers and controllers. Note, the order of controllers determines the order in which key bindings appear in the key binding menu. The earlier the controller is attached to a context, the lower in the list the key bindings will appear. Okay, so there's some ordering behavior. How many instances of the word snake do we have? Helpers. New snake helper, helper comment. So we have a snake helper. Do we have snake key bindings though? Where's live grab? Snake context key, snake. What is this file? Is this context to go? We have setup and helpers. We have a snake helper struct. What is this? The snake file? That's the snake helper go. And then we have the snake controller. What I don't see is how to actually call it. So snake is a new simple context. The window in the window name files, C view snake, snake context key, kind types side context. But what about key bindings? I don't know. So we get finding some information about it, but I still don't see where you actually get to set the. We actually get to invoke it somehow via some command. So what if I? So here's work tree. Can I quit? So if we go into git and lazygit, so let's try running it here and poking around the files. No changed files. What if I go to log? Can I go to this commit? Go to commit. Do I need to change a file? How about if I add to the README? HTML. So let's add to the README and see if, so it picks up this. I still just go to the snash, the changes stuff. Search the current view by text. Snake. All right. I don't know. I still don't know. Okay. So what are we doing? Controllers.go. So this is giving us a little bit more context about what the controllers are doing. This is the reset helper controller stuff. We're monkeying about with helpers. We've got kind of like lining up the helpers, and I think we just saw the helpers are basically the Go QE stuff. So we're kind of wiring things up, and also wiring up the controllers. This is a massive piece of code. This is maybe where you would want like fuzz testing, perhaps, to or you want to make sure changes don't break things, because things matter, like the order in which you add things. So with something that's kind of large and monolithic, you would really want to have lots of tests, and I'm not sure if they do. Hopefully they do. Do we have tests here? Not sure. But we're going to move along anyway. Okay, so here's GUI.go. Do we have GUI stuff? We have GUI stuff. We've looked in the GUI library. So a GUI struct has a Go GUI, which is, I guess, like the standard GUI, the standard object in the GUI library. Sorry, the standard GUI object in the GUI library that we're just keeping a reference to. And then we have I guess like the version of Git we're using, some commands for Git, and some OS commands. I'm not sure what the OS commands are for, but they are there. Maybe you need to interact with the file system and stuff. And then we have the state of the GUI. This is the state of the GUI for the current repo. And I'm not sure if you can browse multiple repos at the same time. I guess that wouldn't make a lot of sense from a UI perspective. But we're going to keep the current state, like maybe are we in merge conflict state or detached head or whatever. We have some custom commands client, I guess, for custom commands, and a mapping of repos to GUI state so that we can restore the original GUI state when returning from a subrepo. Okay, so we do have multiple repos, and the use case is a subrepo. I'm guessing like a Git submodule thing. In repos with multiple work trees, we store a separate repo state per work tree. Okay, so we're just storing a bunch of stuff. We've got this large GUI struct, and we're storing just like a ton of stuff in it. Again, somebody was asking me about whether it's good to have large structs. This is kind of another big struct that contains like all of the info, and I think that's fine for Go. What else do we have? We have a status manager, an updater of some kind. Whether we should show recent repos, some mutexes to control access. I'm not sure. I guess we might have like channel stuff and so on. And some like kind of helper methods like get repo path stack set is refreshing files. What are we locking? So item operations mutex.lock. So if we, whatever this is, set item operation, before we do some stuff, we're going to lock this particular mutex, the item operations mutex. And then we'll defer unlocking it so that it happens when we're done. And then we're just going to add to this list. So this is just some some like list protected by a mutex. And then repo state is some struct that has things like models and modes, whether the main panel is split, whether we want to limit commits, maybe by some number. I'm not sure what sort of support we have for snake here, but I guess none. And then GUI common has some would seem to be functions that are, I guess, common maybe to multiple contexts or windows. Things like running a subprocess, logging action, log command, push context. I guess pushing context onto some container of context or something. So just like I guess maybe like utility render, utility methods. We also have render, which we'll call self.gui.render. Sounds good. And I guess I haven't been really watching the capitalization, but for example, here in Go, lowercase is private and uppercase is public. So if you have somehow a GUI common thing, you can't call the underlying self.gui config because GUI here is lowercase. But if you have a GUI common, you can call capital G get config, which will get essentially access to that private method for you. We have GUI driver, which has some struct. We've got a GUI or a GUI pointer, and a channel is idle channel, maybe whether we are idle, and a toast channel, maybe for doing like pop-ups and stuff. And press key is maybe called when a key is pressed. We will check all toast acknowledged, and then get key on the key string. I guess GUI driver, this might be for driving the GUI for testing. So I'm guessing this is maybe like programmatically press a key perhaps. Let's see if we get a comment. This gives our integration test a way of interacting with the GUI for sending key presses and reading state. Yeah, okay. Cool, so this is for integration testing, which is good. I like to see that. Layout.go is, I'm gonna guess, for layout. So we have the, this kind of terminal. How do I get back? I don't know what I did to get rid of these screens, but it's got this kind of like multiplexed screen stuff here. So I'm guessing this is what it means by layout, like where are these rectangles in relation to each other. So a layout is called for every screen re-render. For example, when the screen is resized. So let's resize the screen. So I guess we just call that function. What if I make it so small? Not enough space to render panel. That's what you think. Snake, 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 snake. Okay. So this is layout stuff. So what do we want to see here? I'm not sure. Prepare view. We're delegating, I guess, to what I think is the GUI stuff, because we've got this GUI.g, which I think is the GUI object. What else do we have? We've got this layout function, which is the one that I used to be at before I jumped around. So we check if the view setup. I don't know what that means. We'll set G highlight to true. I think G is the GUI, right? Yeah. The GUI there. We get the information string, I guess, from GUI and the app status by calling one of the helpers, which I think, again, is delegating to GUI. And then we get the dimensions. And we get the, preview main. So reading more lines into the main view buffers upon resize. Okay, so somehow we get the main view. And if it's non-nil, we get the size. And we get the new height and I guess the difference between the height and the previous height. And if it's bigger than 0, then we will what? Call view buffer manager app on main. And if we get that, we'll call read lines on the height diff. I guess we'll read the new lines perhaps. And then whatever secondary is, maybe there's like a secondary window. And then we'll create this, I guess, to keep track of context that we need to render. And then we'll get that from somehow from the view dimensions. So we'll pass, we have this function. We're going to pass in the view. No, sorry, we're going to pass in the context. We're going to get back a view and possibly an error. And somehow we're going to check the dimensions and I guess make sure we can render stuff. And somewhere it'll do things like make sure that, what's this error when I made it too small? Space, not enough space. Somewhere there's going to be some error condition that corresponds to not enough space that will go through the translation stuff, which we saw before. But we could look up the string that corresponds to that error message, but I'm not going to do that. All right, here's main panels.go. We have run for task view, which I guess you can give it a task, right? So like some update task. And we're going to just switch on the task and call it a corresponding handler. So for example, if it's a render string task, we'll return GUI.newStringTask. And if it's a render string with scroll task, we'll call new string task with scroll, and so on. We can move the main context to top. And this should ultimately either it's going to boil down to calling, I think, the GUI library, all this stuff. Or we might go down to some geometry methods that are like, check if these two squares are overlapping or not, that sort of stuff. We've seen some of that stuff before in other repos. But eventually kind of that's how this sort of stuff will go down, I think. We have refresh main views and so on and so on. Split main panel just sets GUI.state to split main panel to whatever you passed in. So that's just setting some Boolean, and then I'm not sure if that kicks off some event somehow, or if there's a loop that decides when to render that. And then views, we have what? A bunch of different views, like files, status. First layer. Ordering within this layer does not matter because there are no overlapping views. So I don't know if this space is supposed to indicate a layer. Bottom line, pop-ups. Yeah, it seems like somehow this list is supposed to have structure, but it's not actually reflected perhaps in the structure of the list. So I don't know if we need to know somehow that this has so many entries or whatever. Staging, okay, so in the top layer, we have things like status snake. What? Submodules, work trees, files, etc. And then in this stanza or whatever you want to call this, we have staging secondary, etc. And then we have this extras thing, and then options, app status information, and then some pop-up stuff. Yeah, it really does seem like this list is kind of has an implicit structure based on essentially the index. And then we have create all views. And these are frame runes. So these are, I guess, like kind of like UTF-8 characters that, or I don't know, but basically characters that are drawing stuff. Let me make sure I look up what a rune is. What is a rune? A character defined using code points in Unicode. Yeah, Unicode. Okay. So let's see if we can, yeah, so we have this border here, and I'm guessing that this border, it's a single border, and I'm guessing that it's this, maybe rounded? Is this rounded? No, this one. How do we get the double frame? I'm not sure. Can I change the theme somehow? Toggle stage, etc. Refresh, next screen mode, previous screen mode. So I guess I can cycle through screen modes. Open menu. Is this the menu? What else? What else? What else? I don't know how to like change the theme. Switch to a recent repo, refresh, next screen mode, open menu, which I think is what is just question mark, right? View filter, open diff menu, toggle some stuff about white space, redo, push, previous tab, etc. Can I click on ask a question? Execute, enter. Or do I just, what? Maybe there's a way to enter a command. Open command log menu. So that's search. Edit files, commit changes. Tree view. Toggle the file tree view. How that? Okay. View custom patch options. View merge rebase. Increase size. Scroll up. Scroll down. What if I just did lazygit? Enter command. So what is this? What is this showing? What if I just do a search for command? We have custom commands. We have a list of git commands. Yeah, I'm not sure. You can add custom key bindings in your config.yaml. All right, well, I don't know. And then, so we'll review. I'm not sure when we get to see the double runes or the rounded runes. But we basically keep track of these runes, and then we iterate over the ordered view name mappings. And we call prepare view, and somewhere we're doing something with these runes. I guess we're setting the map. The prepare view is returning some mapping.view pointer. And we're setting the frame views and color, etc., on the mapping we get back based on the stuff we have, like the theme and the frame runes we defined up here. And then we're setting things like background color based on the color default, etc., etc. This just so this is, like it said, setting up the views. Cool. Snake title. Snake title is set to GUI.c.tr.snaketitle, and the foreground color is green. But that's really all I see about snakes. And I think that's enough for now. So that was lazygit. I didn't figure out how to play snake. If you use lazygit and you play snake every day, I want to hear about it in the comments. If you use lazygit and you just know how to invoke snake, also let me know. And that's it for now. This was the first time kind of experimenting with recording multiple in one go. I feel like it worked reasonably well. Next time I'll try to start closer to the to the announced time, and hopefully we can get like maybe 3 of these in, and then go from there. This may be the new way that we try to do things. So thanks for watching. Thanks a lot to the folks on the chat.